It's Algebra 2, lesson 13.3, trig functions of any angle. So we've dealt with right triangles before. Now we're going to deal with obtuse triangles, evaluating trig functions with any angle, looking at some real life problems. Typically those involve just the angles, measurements and stuff. On page 784, something called a quadrantal angle. That's how you pronounce that word. It's a simple word to pronounce, even though it looks confusing when you look at it at first. Quad, y'all know that prefix right there. You know that means four. Quadrantal just means it falls on one of the axes. So you know if it's in standard form, it's going to start on the initial ray right there, and then it's going to open up either positively going up or negatively going down. A quadrantal angle is going to fall on one of the axes. So it's an easy measurement to determine depending on how far you go. So it's either going to go here, it's going to go all the way to 180, it's going to go to 270, or to go all the way around to 360. And again, you can continue past that by doing more revolutions, both positively or negatively. Quadrantal angles, again, easy measurements to find because they fall on an axis. A reference angle is what I was trying to explain to you guys earlier. It says if theta is an angle in standard position, its reference angle is the acute angle formed by the terminal side of theta and the x-axis. That's important right there. The x-axis. You don't want to use the y-axis. What that means is, again, in a plane, it's going to be in standard position. If the angle opens up, let's say to here, going all the way to the fourth quadrant, if it opens up to there, you are not going to use this part of the x-axis as your reference angle. You're going to create a triangle here and use this as your reference angle, the one that we have drawn as a triangle there. You're not going to use the angle that's opened up all the way. Because again, we can use trig functions. We can use SOHCAHTOA, as we're all familiar with using. We can use that of the right triangle created using a reference angle there. Here's general definitions of trig functions. It says let theta be an angle in standard position and x, y, or that coordinate, be any point except the origin. So you're not talking about this point here. Any point on the terminal side. The six trig functions of theta are defined as follows. The sine of theta, so your sine is going to be the opposite over the hypotenuse. That's still the case. SOHCAHTOA, sine is opposite over hypotenuse. So from this reference triangle there, from that angle, your sine is going to be the opposite over the hypotenuse. So in this case, the opposite is y's value. Okay, where does y over r come from? This is important right here. Where does y over r come from? Y, remember, this is your y-axis here. So y represents this distance. What I have drawn in red right there. It's that distance. That's y. Your r is your radius. Your r is this distance right here. So remember, sine of theta, SOHCAHTOA, the S-O-H, is sine is opposite over hypotenuse. That's what SOHCAHTOA tells you. Opposite over hypotenuse. From this reference angle here, the opposite of that one is, so you're looking at just this part. It's easier just to pull it out. You have this angle given to you. You have the opposite, which right here is y, and you have the hypotenuse, which is r. So to follow up on that, this would be your x value, because that's how far your x value is. So x, y, and r. And then we're using the same six trig functions that we learned for right triangles, because this is all we created was a right triangle. For the cosecant, remember, cosecant pairs with sine. It's just the inverse. You just flip it. Not the inverse. It's just the reciprocal is a better way to say that. Instead of y over r is r over y. So we're going to do the same thing with the other ones. Sine, cosine is next. Remember, cosine, the CAH part of SOHCAHTOA, not SAH, CAH, is adjacent over hypotenuse. The same triangle right here. This is R, this is Y, and this is X, and this is the angle that you're referencing. So adjacent is X over hypotenuse R, A over H, or X over R. That's cosine. And secant pairs with that one. Remember, secant is just the reciprocal of cosine. So secant is, instead of being X over R, is R over X. The last one is the tangent. And again, the same triangle you use in this one here. Your triangle, this is your reference angle. This is your Y. This is your X. And this is your R. Your tangent, SOHCAHTOA. Opposite over adjacent. Opposite is this one here, Y. Over adjacent is this one here, X. Y over X. And again, tangent pairs with cotangent. Use the reciprocal instead of Y over X, X over Y. So these are your 6 trig functions using a reference angle. That's paired with that obtuse angle that starts in standard position. And then the last part just simply says, for acute angles, these definitions give the same values as those given by the definitions in lesson 13.1. So acute angles, angles that don't open up bigger than 90 degrees, you just use the angle itself. So we'll just do it here if it's an acute angle. You don't need a reference angle for something that's smaller than 90 degrees. Here's example number 1, evaluating trig functions given a point. So it says, let negative 5, 12 be a point on the terminal side of an angle theta. In standard position, evaluate the 6 trig functions. So what we have, this angle opens up this way, and it creates this right triangle right here. It creates this right triangle, negative 5, 12. This right triangle right there is the one we're looking at right here. So we need to fill in A, B, and C right now. Okay. What? We know that this point right here is negative 5, 12. So 2 of those sides, one of those sides is going to be 5, not negative 5, and the other one's going to be 12. Okay. Which one of those sides is your X value? Well, let me do it this way instead. Let's call this one right here A, this one right here B, and this one right here C. Which one is A? Is it the let's call it negative 5 for a second. Is it negative 5 or is it 12? Which one is your X? Let's do it this way. Which one is your X value? Negative 5 or 12? That's easy. The negative 5. So think of this reference triangle or this reference angle, however you want to say it, comes from this side here. It comes from that x-axis. So that's the x-axis. So which one is the x? Which one's on the x-axis? A, B, or C? Got to be able to see this. A, B, or C? Which one's on the x-axis? This same triangle right here goes right there. So which one's on the x-axis? A, B, or C? A is. So in this case, A is X. Which one's on the y-axis? A, B, or C? Again, look at it again. Which one, it's not on the y-axis. Let me say that again. Which one represents the same distance on the y-axis? B or C? Remember, this here is your y. Which one follows that same position? Those B or the C? Which one follows the same position, the B or the C? Got to be able to see this. This is impossible if you can't see this. Your B is the same as Y. B equals Y. I got it written upside down like that. So then C in that case is R, or your radius, because it's just talking about the radius of our unit circle. We know how to do circles. We've been exposed to circles. So that being said, let's look at what we have. It says x squared plus y squared is equal to r squared. So we need to take the square root of x squared plus y squared. The square root of -5 squared is going to give us 25, plus 12 squared is 144. Those together give you 169. So the square root of that is 13. So your r value then is 13. So using x is -5, y is 12, and r is 13, you can write these trig functions. So all we're dealing with now, we're not dealing with the obtuse triangle anymore. All we're dealing with is the reference triangle, where C's value is 13. B's value is, we have that one given to us, 12. And X's value is 5. We're not using -5 because distances aren't negative. So that being said, the sine of that same triangle, the sine of it is the same triangle here. This reference triangle that we just created, this one, is 13, 12, and 5. This is your reference angle, this one here. The opposite sine is SOH, the opposite over the hypotenuse, 12 over 13. That's where that comes from. Remember, sine pairs with cosecant. Cosecant is the inverse. Oh no, it goes straight to cosine, excuse me. Straight to cosine. Be positive. So your cosine is CAH. CAH. Adjacent over hypotenuse. Adjacent is -5. We'll talk about positives versus negatives on the next part of this lesson. But -5 is your adjacent over your hypotenuse, 13. The next one's your tangent, TOA, T-O-A. Remember, tangent, same triangle. We got -5 down here. We'll call it 12 and 13. Tangent is your opposite over your adjacent. So 12 over -5. Y over x is 12 over -5, which is -12 over 5. Cosecant pairs with sine. It's just the inverse. This one right here, we had sine a minute ago. 12 over 13 is 13 over 12. Secant pairs with cosine. Remember, cosine, we did that one first, is -5 over 13. The cosecant is the reciprocal of that, -13 over 5. And the cotangent pairs with tangent. Tangent is -12 over 5. Tangent is the reciprocal, -5 over 12.